Good afternoon and welcome to today's OR Today webinar. Today we are joined by Seth Hendee, Clinical Education Specialist for Healthmark Industries, where he provides expertise on medical device processing, policy writing and SPD education. Seth is a member of multiple AAMI working groups, including those responsible for ST108, ST108 and ST108. OR Today would like to thank our sponsor, Healthmark Industries. Since 1969, Healthmark Industries company has developed and marketed innovative solutions to aid healthcare facilities in their delivery of surgical instruments and other life-saving medical devices to patients. Healthmark Industries' mission is to continue to innovate, support and serve the healthcare provider industry and support services that make it possible to deliver quality healthcare. So for more information, please visit hmark.com for more information. Today's webinar is eligible for one continuing education hour from the California Board of Registered Nurses, and you can obtain your certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1CE certificate, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us here at webinar@mdpublishing.com. Just a quick reminder that if you have missed any of our past OR Today webinars, you're still able to view them on our website, ortodaywebinars.live. I just want to remind everybody that OR Today is pleased to support Periop Connect, which will take place October the 25th and 26th at the Omni New Haven Hotel at Yale, New Haven, Connecticut. If you'd like the opportunity to be a presenter, please see the flyer in the handout section of your dashboard or visit periopconnect.com for more details. Okay, let's kick off today's webinar by giving away one of our OR Today live lunch bags to the attendee that can tell me the answer to the following trivia question. It's St. Patrick's Day on Sunday, so which plant is the symbol of Ireland? Answer now using the questions feature on your dashboard, and I'll reveal the answer at the end of the webinar. We'll have a live Q&A at the end of today's presentation, so please submit your questions anytime using the questions feature on your webinar dashboard. As I mentioned earlier, our presenter today is Seth Hendee. So Seth, you may begin whenever you're ready.
Perfect, thank you very much. I'm just going to preface this program a little bit by saying there's a lot of chatter in the industry about this standard, and that happens quite a bit when AAMI publishes a new standard. I'm hoping that you get a couple of things from this. There's absolutely going to be some detail in here that's good to know, but I also want you to walk away, with the thought of an action plan. And I'll tell a little anecdote as we go along here, how another standard caused the same kind of stir and put a question into people's mind about, hey, what all does this entail and where am I at? And hopefully this has you walking away with a little bit of an understanding of, okay, there's this new standard, am I on the edge of the cliff? I've used this very kind of as a tongue-in-cheek thing to say this program is to give you a chance to take a deep breath and maybe step back from the edge and let's work towards getting this complying with this standard correctly. Quick disclosure: these opinions are mine, the presenter, but I'm going to use a ton of tables and things like that from the standard to give you an idea of where we're trying to get with this. That's just a quick disclosure for that piece. And so our objectives today are going to be to discuss the difference between a technical information report, which is what water was considered to be, a TIR, and now it's a standard, and why that's different, what kind of difference that makes. And then we're going to discuss additional recommendations to ensure water of a sufficient quality is used in your sterile processing department. That's important, and we're going to talk about what kind of water stuff is likely already being done, but that's kind of the scary bit of this. People say, well, I know some water things are happening in my department or in my facility specifically. Now there's this new water standard. What does that mean? That's going to be one of the questions that we try to answer here today. So first thing, what is a TIR? What's a technical information report? It is a review of technical issues relevant to a particular technology or a statement of expert opinion, sometimes both, right? It can include discussions of different sides of an issue to try to gain some technical aspect or knowledge of something so that you can make continued better decisions about that subject in particular. So when a committee, an AMI working group committee, believes that there's a procedure for developing a standard that would unduly delay the creation of said standard. So a TIR actually can come out more quickly than a standard. So sometimes people say, well, we'll put a TIR out there because we want to get guidance into the field quickly and to do this through a full standard or through the full standards development process. It's going to take a little more time. TIR may serve as an interim statement by a committee working to develop that standard, and a TIR also can provide additional guidance through AMI and then through the American National Standards Institute, because that's kind of the hierarchy. AMI to ISO, or I'm sorry, AMI to ANSI, ANSI to ISO. That's kind of how these work up, and that's how AMI documents get represented up through that kind of standards guidance hierarchy. So here's the thing, water as a TIR was not sort of an interim statement. As a TIR 34 was around for several years. So it was just that water was considered something that had technical things to consider, technical aspects to consider, good information to be put out, but not, not generally something to survey to, right? Not something to be elevated to that level. Well, TIR 34 is now ST108. It is a standard. So as a standard, these are consensus documents, right? It provides requirements, specifications, guidelines, or characteristics that can be used to consistently ensure that a material, product, or process or service are fit for their purpose, right? So that, again, that elevates it, not just good information, setting a set of requirements or recommendations to say anything below this line is really not considered best practice anymore. AMI developed standards documents aimed at enhancing safety for patients, efficacy of processes, really best outcomes, best practices for patient, best practices for a process means a best outcome for the patient. Standard may recommend to a manufacturer the information that should be included with a product. It could give basic safety and performance criteria. It can give conformance measures. That's a lot of what's going on in this standard. And they can be used to assess compliance. The inclusion and design specifications of a standard is permitted when circumstances warrant. So that's another thing, and we're going to talk about it here. Another thing to understand about a standard is what's included and what's excluded, because that does get very specific when you talk about complying. The real question that you're asking yourself is, Seth, that's great. It's a bunch of information. Why does this matter? Okay, what does that matter? Well, in general, TIR is considered informational without being overly prescriptive about a specific process. So as I said, hey, industry, there is a lot of good information about water. Here it is. Here's what we think about water and that kind of stuff. But that's really kind of the problem. Because it's informational, it's generally considered to carry a little less weight. How many times have you heard someone say, I got surveyed against TIR 34. Somebody came and asked what my compliance is with TIR 34. You don't hear that very often. Now, what is your compliance with ST108, which is probably in the SPD realm is our probably most famous standard? Yeah, that you hear that all the time, because standards do get prescriptive. They do give specific recommendations for attaining quality results on a subject, right? So the reason that can be done is because a standard is a consensus document. It requires a certain level of agreement within a group and a 15-day public review. So that says, hey, a working group came together of subject matter experts and worked this out, and then we even put it out to the public to say, okay, this is something that is going to go out into the healthcare sphere and something that we expect people to comply with. And so that's why it carries more weight, right? There's more rigor, there's more review. And once something becomes a standard, it is something that now, the Joint Commission can say, does your organization follow AAMI standards? And if the answer is yes, then ST108, the standard on water, is something that you can expect to have some questions about. Regardless of whether the information comes from a TIR or a standard, if the information is incorporated into your policy, a survey organization can cite you for non-compliance. So again, just think about that. If you had incorporated a piece of the information about water from TIR 34, if you put it in your policy, you can be surveyed to that policy, and that works for anything. Once you write something down in your facility, departmental, organizational policy, it's on the table to be surveyed against for non-compliance. This is really the big thing that people are wondering about here is how does this affect SPD? Now, I shouldn't say just SPD, I should amend this slide. How does this affect processing departments? Because this could be endo too. And we'll talk about why the real thing is, how does this affect processing departments? And it's with the term point of use. And I'm going to explain that when we get there, that now there's a focus, because you're very likely able to say, I have a water guy. We have a facilities water guy. We may have a facilities water management team, and I am sure they are doing some things. I am sure the boiler is getting tested. I am sure our potable water is being tested on a level, so everything's fine. ST108 takes it beyond that, and we're going to explore that a little bit. It takes it beyond that into point of water use, and that's where you might be going, okay, wait, now I wonder if I am in compliance. And that's the question that we're getting a lot. Okay, so it really depends on what you're already doing, right, at that point of water use. So what kind of testing is already being performed? If you ask yourself and you don't know, that's a gap. If you ask yourself and you say, I do know what the answer is, and the answer is 0 testing at point of use, okay, identified gap right there, and then we start from there. So how often is it being done? Again, some testing is being done, but aren't sure of the frequency, then we need to see if that what's already being done complies. What water treatment systems do you have in your facility? What's your role within the department? And you may go, but I'm going to tell you really shortly here what difference that actually makes. And then what training and communication infrastructure already exists in your facility? If you can't answer these questions, or you happen to know that they're not where they need to be already, then each one of them has a greater effect on what you have to do to become compliant. I just want to lay this out, so I'm not going to take a ton of time to do it. These are basically the 4 main categories that you're going to kind of work with water. And if you didn't know, potable water is water that's been treated, meets EPA guidelines. That being said, you've seen those Brita water filtration commercials and things like that say, would you like a glass of water with an acceptable amount of lead? Because that exists, right? That's the true, right? So even though something's potable, we have to ask ourselves, does that make it ready for point of use for medical devices? Maybe not, right? So there's an important thing to understand. What is likely happening to most places, my home has a water softener. That is the kind of the most basic general treatment that water gets. We've got a lot of excess minerals, calcium and magnesium in the form of calcium carbonate. We need to get that out. It causes staining. It's a problem. So you soften your water. In medical device processing, critical water, sources of critical water, and the most prevalent are DI and RO, are ways to highly treat water, and that highly treated water is much more effective for especially processes like final rinsing and being used in some automated equipment. So DI is when water it goes through an ion exchange resin and it removes ionized salts and things like that from water. And so the resin bed has to be changed. If you've ever heard your water person say, yeah, the DI resin bed has to be changed. That's what they're doing. They switch it out and it keeps the system going. Often a lot like adding salt to your softener, right? It needs a refresh. RO is membrane separation. And so there's molecular sieving that goes through this very, very small membrane, and it actually pulls out things. Any contaminant with a molecular weight above 100 gets pulled out. So this is generally what we're talking about. The water used for processing is either going to be potable, which is your utility with some softening, or it is critical water, which is usually DI or RO. It can be sterile distilled, although most people don't have that piped. That's something that you may have in your OR in bottles. You can get it in gallon jugs, but you don't generally have that as piped in coming into your facility. So what is the scope of this standard? We're right at the beginning, and I said understanding that's important. This standard establishes the minimum requirements for water quality used at different stages in the processing of medical devices. It's pretty straightforward. That's very broad, but that's a pretty straightforward statement. Okay. These requirements are established to assist medical device processing professionals in selecting the appropriate water quality needed for cleaning, rinsing, disinfecting, and sterilization of medical devices. As I said, that's a pretty wide swath. Cleaning, rinsing, disinfection, these can all be different. They can all have their own different needs and requirements. And so that's seems a simple statement to make of the scope, but it's actually a pretty wide scope. As I said before too, the inclusions and exclusions are important. So a couple of things that I thought of particular note: responsibility for the water management program. Let's say you're in infection prevention, they're often the person tasked with walking around a surveyor. Can you articulate your water management program? I'm going to admit something to you. I worked in SPD at a high level within the department, and water management program, all I would have been able to say to you was, we've got a water guy, and the water guy does water things. And I know that sounds silly, but that was really my understanding of our water management program. I'm telling you, with this exclusion or with this inclusion, that's not quite enough. You should at least be able to talk about the responsibilities of the people within that management program. Categories and requirements of water for medical device processing. People should be able to speak to it. If you're not familiar with the terms critical and utility water, we need to do something about that. Selection of water of the appropriate quality. I'm talking different stages. Is there a different stage for rinse, different quality water for rinsing as for use in the final rinse and high level disinfection? Absolutely, and we need to know, and people need to be able to speak to it. Considerations for ongoing maintenance, monitoring, and quality improvement of the water treatment system. Again, I knew that we had water treatment, but ongoing maintenance, the schedules for it, even really the right person to call to get that information into a surveyor's hands was beyond me, because we didn't have a structure in place for that, right? There are a few exclusions, I won't go through them, but you don't have to apply this in the hemodialysis unit. They're not going to go to your lab and say, hey, do you guys comply with ST108? They're going to be like, no, actually, sorry, that doesn't apply to the lab. So the exclusions are also important as well. Okay, roles and responsibilities become a big thing. I want you to think, now this is, again, as a person, and especially if you're an OR director who has purview over SPD, and I'm seeing that a lot. Facility that I worked at before starting with Healthmark was reporting up through materials management, and in the last couple of years, they saw the need to have a clinical department, which SPD is, sterile processing is, report to another clinical department. And they actually shifted away from materials management to reporting to the OR. That meant the OR director had responsibilities for medical device processing personnel. And in this standard, they have to say, okay, these are people that are under my purview, and do those personnel that are responsible for cleaning and disinfection and sterilization of devices, have they received education, training, and competence verification on the importance of water? If your answer is we do zero training in our SPD or our endo or any place that processes device, that uses medical devices that get processed at point of water use, if they haven't been trained, educated, trained, and demonstrated competence around water, we've just received a gap, right? We've just identified a gap, and that's something to address. Patient risk associated with improper use of water, and when water has the wrong characteristics, water monitoring that should be performed in a processing area. Medical device processing personnel are responsible for monitoring processing equipment and medical devices and looking for damage and discoloration that can be indicative of water issues. I'm going to show you, you've got to hang in there. I want to show you a couple of pictures at the end of something where a perceived water issue actually unfortunately brought down the level of inspection, and that can turn around and cause problems. So that third bullet there is going to be important when we say, hey, understanding water and understanding water quality and understanding lack of water quality, how does that negatively impact things? I'll show you a couple of pictures and that'll make you go, okay, I can see that. And so they should be given time and resources to complete these activities. So there again, are we dedicating any time or any resources to training competence around water? If the answer is no, they need to. I'm going to show a few tables. This is just table one, so pay attention, right? Pay attention to the tables that we see in standards. SPD responsibility in table one as a manager that is part of the multidisciplinary team. Do you have a multidisciplinary team that considers aspects of water, and especially when they come out of compliance? If the answer is no, you need one. And then as a person who processes medical device, someone in that department needs to be part of that team, right? They have to participate in general assessments of water quality and understand how those happen and how they affect things. And then as a medical device processing personnel in conjunction with an engineer, your assurance of proper water quality at various stages. So there you go again. That's not to say that we're placing all the responsibility for this on an SPD technician or on an endoscope processing technician. It is in conjunction with the clinical water engineer, right? But we are assuring proper water at proper stages, yes? And if the answer is no, there's another example of non-compliance. What about risk analysis? Well, you're going to see that in a lot of things. A risk assessment is something that we should all be familiar with. We should have a structure for it in our organization so that we can say, something happened that it was unexpected. What do I do? Well, I get that question a lot as a working for a company that makes devices and makes product solutions. People say, hey, Seth, this happened this same way 8 times, but on the 9th time it was different. What do I do? I have to tell you, many of those answers are, look, things are very specific for your organization, and especially with water, your infrastructure makes practically every facility different for how you might deal with something. So having a risk analysis is important. First and foremost, what about the physical appearance of water? Every time someone in a processing area turns on the tap, are they actually looking for color, clarity, the absence of particles? I've seen things where chemicals get overdosed and things like that, where people really aren't paying attention, using their automated dosers and things like that. You wouldn't be able to tell if that water was clear or not. They're adding it, there's a lot of bubbles and foam, and they overdose, and you go, I can't even see the bottom of this sink. How would I know if there was particulate in it? How would I actually assess its color and clarity to start? Inorganic contaminants of water, pH of water, and water temperature. The reason I highlighted these things is because those are just, to me, are kind of ridiculously simple. If you don't already have a water level mark in your sink that has a thermometer incorporated, or an automated doser that has a digital thermometer, you're missing something, right? So these are things I call, these are things we should already be doing. We should be, you shouldn't be thinking to yourself, oh my goodness, do I even know if anyone's checking the temperature of the water that goes into their processing sink? If you're asking yourself that question, you've got a long way to go. These are things, some of these things are things we should already be doing. So what is our performance qualification for water? Well, as I said, there's utility water, which is your potable, maybe needing some softening utility water. And then critical water is your highly treated water. So it kind of depends. Here's just the basic table, categories. Categories and performance qualification for water. So what kind of measurements in water should I be looking for? pH, total alkalinity, bacteria, endotoxins, total organic carbon, color and turbidity. So that's one where people are like, wait a minute, what? Well, honestly, I see people not evaluating just the appearance of their water. They turn on the sink and they walk away. And I would really be able to actually come in and say, hey, I'm not even watching you witness water enter this sink. So how are you doing anything about are you even checking the color and turbidity? Because by the way, you should. And then of course they have a list of ionic contaminants. And so this just kind of says, hey, here are some baselines. Here are some levels that we're looking for. And we'll get into actually methods for testing for them, and some other specifics as we get a little farther in. But there's the basics, right? A lot of SPDs can be a part of testing for about half of these easily. pH, total alkalinity, color, and turbidity, right? Though again, you can be part of that because these are easily done, they're quickly done, and they don't need a ton else to go in with them. The question is, are they? So let's first talk about hardness. This is the characteristic of water that we need to fix. Water hardness is the concentration of calcium and magnesium expressed in terms of calcium carbonate. So those and other minerals bind with cleaning agents and detergents, and they really stop them from doing their job well. Instead of protease enzymes and instead of those things grabbing onto soils and helping remove them, the hardness minerals tie them up. So you may be using it. We talk about this sometimes. People say, well, what's a sign of hard water? Well, if they say that your dosing can be a ½ ounce to an ounce per gallon, and you try to use a ½ ounce and things aren't getting clean, that could be an indicator that some hardness minerals are tying it up. And so you're not able to use your chemicals at the lowest dosing because some of them are getting used up with hardness minerals in your sink, right? Just kind of something to consider when you do your risk analysis and things to think about moving water quality forward in your organization. How does it affect cleaning? It's that same thing that I talked about, right? It uses up some of your chemistry, so you use more soap. There's another thing to kind of consider when you're looking at a washer, just to wonder how that stuff is going, is that most detergents are supposed to be low foaming. So if you see a lot of foam and things like that, you might be going, why is that happening? Well, hardness can be part of it. And then of course, anytime you look in and you see scaling on the inside of your equipment, you should be going, where do those deposits come from? Well, they come from those hardness minerals sticking to the sides of your thing. This is just a quick little overview. 0 to 60 parts per million is considered soft. 61 to 120 is moderate. If you're anything over the 120 range, you got to be like, hey, we should be doing something about this. Even as I say, at 120, you may be considered, but you're right at the edge. And the benefits of a softener might come into play when you say, wow, I actually choose a little less chemistry. I install a water softener and I feel like I get a little bit more out of my chemistry. I get a little bit better cleaning. Next, let's discuss pH, right? Our potential for hydrogen. The pH scale measures the acidity or alkalinity of a liquid. The scale starts at 1 and goes up to 14. So your acids, your bases. The midpoint is 7, although that's where we say is dead in the middle. There's a little range for it where it's still considered neutral. But in America, we try to hit that 7 with a bullseye. What about alkalinity? Alkalinity is a measure of the buffering capability of water to resist changes in pH. We do a lot to water. We beat it up. We add chemicals to it. We put instruments in it. We perform agitation to it. We perform sonication to it. We use it for impingement, which speeds it up and glances it. We are hard on water, and those processes, and in those processes, the pH of water can change. And so, good alkalinity, or alkalinity at the right level, kind of keeps water stable when we're mean to it, right? When we use up its capacity to stay. This is interesting. I gave not this presentation, but I gave a water presentation before, and someone was like, I talked about alkalinity as the buffering capability of water, and they said, no, alkalinity is just whether something is basic or not, but it really isn't. Alkaline as an adjective is relating to or having the properties of an alkali metal, having a base, right? Especially in a solution, having a pH more than 7 is considered alkaline, right? So do certain crops grow better in an alkaline soil? Absolutely. Alkalinity is different. That's the chemical measure of water's ability to neutralize acid. So it's a measurement of the water's buffering capability to resist changes in pH. So something like, can certain chemicals be added to a pool to achieve a desired alkalinity? Yes, you've got people in and out, you're adding shock, and you don't want your pH to jump all over. And so you can put that kind of stuff into your pool, right? You can use chemicals to try to do that. Okay, so where and by who will these test results be recorded? This is a question to ask yourself. You're going to start doing, if you're not already, water assessments and taking measurements at point of use. If you take those measurements, if you already are and aren't recording it, or you haven't started and you do take those measurements and you don't record them, you might as well not do them. So, like the first thing to do is to say, okay, I'm going to take water measurements in a place I wasn't before, or I may increase the measurements that I was taking in a place I wasn't, and I need to write them down. This is just the one thing I want to bring to your mind. What if you have an SPD person doing some of these, but then a clinical engineer doing some of the other ones? What if you have an SPD person taking some, but then you contract with a third party company to come in who can take an aseptic water sample, right? How do you check for bacterial endotoxin? And those can't be done with just a dip test. That's a more involved test. And you might have a couple of people taking water samples. Are all of the readings going on the same form? If they're not going all in the same form, do I have a database somewhere where they're married up? Because if you show me half of your water testing and I say, that's great, where are these other 3 metrics that you're supposed to be testing? And you, right? That's a gap. It's a problem. So just number one, who's going to document these and where are we going to keep them? I'm not going to go through this state. I just pulled this from the thing, from the standard itself. What I really pulled this about is to look at the cleaning. Should not exceed 113. Utility water typically 77 Fahrenheit. Why? Because water temperature is important. Okay, the denaturing action of heat on blood makes it insoluble and interferes with cleaning. We can actually cook it on. So why do they want it below 113? That was part of it, our initial rinse below 113. We're trying not to denature the proteins in blood because that actually makes them stick instead of rinsing them away. So what do? We start with a cool water rinse. Low temperature at the start prevents denaturing. High temperature later gets maximum efficiency out of detergents. Enzymes can be sluggish, for lack of a better term. So most people have a pretty good or a target range where their chemicals are actually very good. They work best around this temperature and they get the best results. So we want that, we want to know that, and we want to try to operate our chemistry within that temperature to get the most out of it, right? And then the other thing and the last thing is that we will end up with thermal disinfection, and that becomes very important. right? As our end stage for things that come out of a washer, if we don't hit our 190 for 1 minute, or our 180 for, I can't remember exactly what, that's a 2.5 minutes or something. If we don't hit those markers, then we're not getting thermal disinfection. What's coming out of our washer isn't what we expect either. So proper temperature varies for each cycle and stage of cleaning. Proper temperature also varies for your cleaning agent, right? Enzymes, non-enzymes, that's a different. If you're doing something with eyes, you can probably play with your temperature a little more because you are likely using detergents without enzymes because the enzymes are associated with tasks. So it really comes down to understanding even the chemistry used, right? And then ST108 also recommends monitoring your temperature in your processing sinks. So what about automated cleaning, right? We could talk about the sink itself, but what affects like a washer or a Sonic or a cart washer, because now a lot of those can do instruments too if they have the right rack and the right manifold. Well, water hardness, pH level, water temp, ionic contamination, microbial level. What is that? Well, that's actually everything that was there before. I did that on purpose. If when we talk about the sink, we're also saying in your automated washer, actually every single one of these things is still important, right? It's still a factor that will affect the cleaning process. And it's why if your washer is not in the same distribution loop, then you may be testing at the sink and in your automated washer. Okay, if I find out that that's the case, and by the way, there's something you should understand about your water. And if you don't, if I ask you that question right now, do you know if testing at the sink is in the same contiguous plumbing and in the same distribution loop as that washer over there? If you can't answer that question, we just identified a gap that you need to close. If you find out they're different, ask yourself these questions. Wait a minute, I have to test a washer. Is my staff able to sample water coming into the washer if they need to? I know that ours couldn't, right? They were not familiar with the plumbing behind the machine to try to go to a sample port, and they certainly couldn't open the washer door and activate the sump pump from the from the control panel to where they were able to stick a little cup in and take a water sample. So if it needed to be taken from there, I can tell you the staff that I worked with couldn't do it. Is your water management team able to take that sample? If you have to do it in a washer and you called your clinical engineer and said, hey, I need you to take a sample of my washer, could they? Maybe, but I kind of doubt it. So what training would you need to be able to make that possible? That is something to consider. First of all, find out do you need it. Second, if you find out you need it, what's it going to take to get that done? This is the whole reason. I won't go through it. I like the little pictures here. We just know that bad bugs live in water. I mean, that's what happens, right? And so this is why endotoxin testing is needed. If you have miles of pipe, now that part I did know, that the treatment that water got before entering my SPD, it went through miles of pipe because the treatment was 3 buildings over. That's where it came in from the municipality. That's where it came in from the city. And that's something to consider. What we're trying to stop is biofilms. If we let water get slack, if we let the treatment, for chlorine that's added to city water and things like that, if we let that treatment get slack with things like dead legs and things like that, or just inactivity, distance it has to travel, if we let those become a problem, then the real issue can be we have biofilms forming inside our infrastructure. So water sampling, point of use, utility water delivered at the point where the washer or decontamination sink or nearby contiguous plumbing. Get used to that word, contiguous plumbing, and understand inside your department what is contiguous and what isn't. Because if you don't know, then you can't say that you're complying. You may be missing something without knowing it. Critical water should be tested at point of use or as close to the point at which the water will represent water that contacts the device. Is that Is that right at the sink? Very likely. I know many automated pieces of equipment that have a final rinse of critical water. And so again, we have to say, is the critical water that comes into the sink the same critical water that comes into my washer? If yes, 1 sampling point. If no, 2. Steam sampling, that's done of the steam condensate collected at the delivery point for the sterilizer. This one in particular, you may end up calling your sterilizer manufacturer, right? Taking a steam sample is not only dangerous because it's hot, it's under pressure in a sterilizer, and that's going to take very specific training or someone who already has the knowledge. Monitoring for your water treatment systems, right? It is necessary that device processing personnel understand the implications of the results of the water quality monitoring. Okay, so they may not have to do it, right? That may be a facilities engineer that's doing it, but again, if I talk to your device processing staff and they go, what water quality management? We've got a problem, right? You know, if I said, what's your frequency? And they say, do we even test water? That's a problem. Now that can be solved by education. Maybe that's all you need, but they at least need something, because to do this means nothing. So although the bulk of that testing is going to be done by maintenance personnel, it is important that test results be made available to the device processing personnel. Again, if I ask, do you do water sampling? And they say, yes. And I say, how often? And they go, quarterly. And I go, that's great. Where are the results? And they go, right? I mean, these are the gaps that you have to be asking yourself. Do they exist where I am now? So where, when, and how often come from tables 5 and 6. So table 5 is monitoring of water at the generation system. This is all very likely to be done by your facilities engineer, or you're already contracting it out. This is the thing that's often already happening in most facilities, because they know it has to be done at that point. The point of water use, table 6, is the one where I have to say, now we're talking about devices, we're talking about water hitting devices. Any place in your organization where water hits a medical device can be thought of as point of use. And are you testing for these things at point of use? If the answer is no, we've got to move that testing forward. We'll try to get through these a little bit. You know, I won't linger on them a ton. Where you have the water generation system, so that's close to the municipality after the last step of water treatment. Point of use is as close to the point where the water contacts the device. Okay, how? I pulled this out because these are parts of the table, so when you get the standard, you'll be able to look. But colorimetric dipstick actually shows up on many things. The reason I've highlighted that and the reason I love that one is because that is very simple to do, very cost effective, and actually pretty simple to read. So it doesn't cost a ton to get them. It doesn't take a ton to train people how to use them, and it doesn't take long to do. And there are several of these things that can be done through colorimetric dipstick. Now, heterotropic plate, that's when we're trying to grow out things. We're trying to see if our water grows anything. That is taking it to a different level, right? And those are the ones you have to consider. Who is really going to do that? You can train your staff to take a sample that can be grown out to make sure they don't contaminate it, that kind of stuff. Or would you hire somebody? That is an option, right? All right, so how often? I pulled these from the table. Again, I know I went quick, but when you go back, you'll find that there are some things that say they should be tested per cycle. There are parts that should be tested daily, weekly, monthly, and quarterly, right? So it just depends on what part we're talking about and which parameter, which characteristic we're talking about. Is it utility, critical, or scheme? And those are then going to vary. The testing frequency in 108 are recommended minimum frequencies, okay? So that's great. And to say you comply, you can say, yep, look, boom, I comply with ST108 because I tested this quarterly. But that's right in that table as well, that these are minimum frequencies. And it goes on to say, the risk assessment performed by the multidisciplinary team may identify sampling points that require increased testing. It also says in other places that if you have a problem, then it would be smart to increase testing until you see that problem go away, and then you might go back to a longer period of time to stretch it out in between. So here's that picture I promised you. These are both from places who said, we've just got hard water, Seth. So don't worry about it, right? I don't know if you look at your spoons. I have a son who looks at every spoon and fork like this because he's always looking for things. They actually looked at these osteotomes, and that's what's on the left-hand side, and said, don't worry, these are just water spots. And we said, oh, okay, are they really? And I know it's a little hard to see, but when we swabbed one of those water spots, it was actually protein. So that's a perceived water quality issue, actually lowering the quality level of the instruments that were going out. They said, hey, it's just a water spot. No, actually, that was residual patient soil. Oh my goodness. They thought, wow, okay, wait a minute. So then these top ones, both of these, by the way, if you're not a device processing personnel, I can tell you both of these instruments are rough. They are rough looking, and you might want to say, geez, why are we still using this towel clip? Because man, that thing looks rough. But I can tell you that the towel clip didn't have any blood on it, and the needle holder actually had blood on it. Now tell me from the distance that we photographed that you could tell the difference. No, but with water quality issues, creating rusting, creating staining, people were like, no, it's fine. We see this all the time. No, we should see this all the time. We should be making sure our water doesn't produce instruments that look like this. And then when we see something that looks like that, we immediately identify it. I just want you to look at the little thing. I was a trainer in my department for a long time, and I got asked over and over again, because people that are new do not want to make a mistake. Hey, Seth, is this blood or is it rust? So we put this little thing on the bottom here at 100 micrograms of blood. Everyone can tell that that's a dried spot of blood. I want you to cruise your eyes down to 0.1 microgram. And there are tests out there that will test down to 0.1 micrograms of blood. Can you see that? If you can, and you should be able to, tell me that doesn't look like just, oh, that's just a watermark. No, it absolutely isn't. That's 0.1 microgram of blood, and we don't want it on our instruments. Little special consideration, I actually threw this in after some flooding that happened in the summer here last summer in Vermont, because there's a specific section, and I even had people call me up and say, hey, Seth, we're on a boil water notice. What does that mean for my SPD? What I love about ST108, somebody said, people need guidance for this. So the special consideration section, section 13, has post-construction and extended shutdown, steps to follow, what happens after extended boil water notices, and steps to take it when the alert is over, what happens for interruptions in services, what happens if I have a repair to my system. And I just threw in something, this is a little dated now, but what is a dead leg? Piece of plumbing, piece of pipe that stops getting used, right? And then water becomes slack on the inside. We had so many people during COVID like slow down and only use half of their AERs because they stopped doing cases. They slowed them way down, or they stopped doing them altogether. And we had to say to people, hey, did you decommission that machine? Did you take it out of service? No, wait, why? What do you mean? Well, actually, in several AER manuals, they will go on to say, if you stop using this machine, if the water stops flowing regularly, you should drain all solution, remove all residual water from internal water lines. Remove all. Wait a minute, and I'm going to show you the picture of an internal water line where you're like, how would I even get that out? Remove pre-water filters and more, right? So if you look at this, there's filters and there's feet and feet of pipe feeding this AER, and this is point of water use. Now the AERs themselves, the exact water that comes out is excluded, but what about the water entering before those filters? Is that something to consider? And again, I just put this in here as a special consideration. If you go through a boil water notice, you better be looking at your AER and saying, if I had a problem, what did that do to the water quality going in? And should I take steps to get this machine back up after a disaster? This is my last thing. is to look at the annexes, okay? Nobody ever does it, and I don't blame them. There's a ton of information, a ton of great information up front in standards, but I make references to things and people say, that's not in ST79, Seth. That's not in ST91 for endoscope processing. And they go, it is. And they say, no, I've read it. Where is it? And I'll say, Annex D. Annex D, yes, that's actually the extra, more in-depth information that comes at the end of standards a lot. So I actually wanted to point this out, right? Annex A I thought was a great one, guidance on the application of the normative requirements, right? So a more in-depth information on water quality at different stages. If you're saying, man, Seth threw out a ton of stuff, but I'm like, like the rinsing stage, I'd like to take a slightly deeper dive. Please flip to the back of the standard and go to Annex A. It's there. Annex D, water used in cleaning and moist heat processes, is a more detailed discussion of the optimal water, again, throughout the stages. And then Annex I is actually my favorite. Typical presentation of water quality issues during the processing of medical devices. Examples of, including pictures of water quality issues. So I just told you that you need to do education, training, and competence around water. Where are you going to find information to do that? You're actually going to go to Annex I, and you're really going to be able to show a processing staff member, you see this stain? That's a problem. And if we were to see that, we'd like to do something different, right? And so think about the annexes, take a look. There's a lot of good information in standards annexes, and that one in this standard specifically, Annex I, is a great one to look at. Okay, in conclusion, facilities, engineers, water management staff has the bulk of the new responsibilities for complying with ST108. SPD, but any device processing personnel have a responsibility to participate in the water management program and in that water management system. And if there's no touchback for water at all, that's a miss, and there needs to be. Some point of view sampling is simple and some require specific tools. So no matter how complex, training is going to be required for the sample to be taken effectively. We can mix up, even simple colorimetric dip tests can be mixed up if we don't do the training and we don't give somebody the time to do it right. And then where is your water management system currently? This is that's the question to ask yourself. I get a lot of people jump right to, am I in compliance? What does it take to be in compliance? How long do I have to be in compliance with ST108? And I'll give you a little kind of quick answer to that as a final finisher here. But to me, this is the most important question to ask yourself. This is the starting line. Where is your water management system currently? If you don't have a strong answer to that question, then it's time to do your risk assessment. It's time to do your risk analysis, find out where your gaps are, and move forward. So to answer this question, I'll tell you a quick little anecdote. Mary Ann Drosnock is our fearless leader, endoscope wizard. ST91, the new version, comes out in 2021. I see her get up to give a presentation much like this, but to endoscope processing. And at the end, they said, we're going to open it up to questions. First hand shoots up. Mary Ann says, what's your question? How long do I have to comply? Okay. For all of these things, this is where you take a deep breath and take a step back. It depends on where you are right now in your facility. What you can truly have problems with is if you say, what new water quality standard? But if you are doing your risk analysis and you find out that you need a water treatment system, and you say, look, that's a capital purchase. And so I have a structure to go through in my department to request such a large purchase, or to make this change happen, or to make that change happen. The fact that you've identified and have a plan to do it is really what most people, the surveyors, want, right? When they cite for something, if you're able to say, here's my remediation plan for this thing you found, that usually takes the sting out of a lot of survey citations. So the biggest thing is not about how long I have to comply. My true question to you is, have you identified the places where you are not in compliance, and have you made a plan to comply? And if the answer is yes, you're headed in the right direction, and that's essentially all that you can do. But if you could, I mean, if you could run out and buy something, do it. But if if you have to request it, and that's the way your system works, then you better find out and get that request in, and then you've done what you can to work towards compliance. Okay. Thank you. If you have any questions, looks like we've got about 5 minutes. And then this is my contact information. Please feel free to email me or to call me if you have any questions.
Great, thanks, Seth. Yeah, we've got time for a couple of questions. I've got one here that says, are there commercially available tests that we can use ourselves in SPD? Is there specific labs that we can send water samples to?
Perfect. Yes, there are tests. Anywhere, there are colorimetric dip tests out there for pH, alkalinity, conductivity. So quite a few pieces of that list of things that you're looking for can be done with those simple, pretty cheap colorimetric dip tests. There are also meters that do it digitally. There's a digital conductivity meter, so that's reusable. You dip it in. Either way you go, they will take a little training to, even, just following the instructions for the colorimetric thing. To take a sample, you're going to have to train them exactly how the unit works. For the, say, if you got one that does digital reading for conductivity, you're going to have to train the person how that works. But yes, there's a ton of things out there. Taking an aseptic sample to send to the lab, that gets kind of specific, right? We need to make sure that we don't contaminate that sample. And then we need to make sure it stays uncontaminated until it gets to the lab. Now, there aren't any lab that can do microbial testing. Well, I should say that most labs that can do microbial testing can do it for water. You do want to make sure that is something to ask, is to say, hey, just so you know, I'm doing this with water. It's not like an endoscope sample or something like that. This is specifically coming from my source water. But there are labs. If you're looking for a little thing, you can reach out and we can talk about them. Try to talk about a few, but they're out there. Listen, there are also companies that will come in and do this entire thing for you. They do exist. They'll come in, they'll take the samples, they have contacts with the lab so they can send them out. So there are a couple of ways to do this. It could be all you, it could be part you, part your facilities engineer, it could be that and a contractor, or maybe contract the whole thing out. That's the decision you've got to make.
Okay, perfect, Seth. We're actually coming up to our hour. So if you have any further questions, please feel free to reach out to Seth. His email is on the screen at the moment. But thank you so much, Seth, for your time today and for such an informative presentation. Please visit Healthmark's website, hmark.com, to learn more about the products they provide for the industry. As promised, the answer to today's trivia question is, of course, the Shamrock. So congratulations to our winner, Jessica Shearbath. Just a quick reminder, you can attain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive a certificate, and you'll be able to download the certificate directly submitted. If you have any questions, please reach us at webinar@mdpublishing.com. Please visit ortodaywebinars.live for more details of all our upcoming webinars and, of course, complimentary registration. Thank you all for your time today, and I hope you enjoy the rest of your day.
Thanks, everyone. Have a great day.